becomes the second order neuron. Then from bipolar cell, we will move on to the ganglion cells or ganglion cells, optic nerve, from optic nerve, optic chiasma, optic tract, lateral geniculate body. So all of these are third order neurons. Then from ganglion cells, or rather I can say from lateral geniculate body, we move into optic radiations. If you remember my neuro-ophthalmology, so optic radiations are actually now fourth order neurons. I can say so fourth order neurons is not a term which we normally use, but they are different basically, and that is why we have taught in neuro-ophthalmology that there is no optic atrophy in optic radiation lesion, because optic radiation becomes a new neuron. It is no more an optic nerve like neuron or no more a third order neuron. So in optic tract lesion and in lateral geniculate body lesion, optic atrophy is present because they are actually the same neuron as optic nerve, but in optic radiation, optic atrophy is absent. If you want to correlate retina with your neuro-ophthalmology. Am I clear, everybody? And that's it about the basic anatomy in terms of the layers, the microscopes or the microscopy. Now I'll just quickly do the blood supply of retina with you guys. Blood supply of retina. Optic atrophy is present because they are actually the same neuron as optic nerve, but in optic radiation, optic atrophy is absent. If you want to correlate retina with your neuro-ophthalmology. Am I clear, everybody? And that's it about the basic anatomy in terms of the layers, the microscopes or the microscopy. Now I'll just quickly do the blood supply of retina with you guys. Blood supply of retina. So retina has a dual blood supply. Number one, the inner 6 layers of retina. The inner 6 layers of retina. Inner 6 layers means ING, inner plexiform, inner nuclear, outer plexiform. Okay, everybody? They are supplied by central retinal artery. But the outer 4 layers become outer nuclear layer, external limiting membrane, photoreceptors, and pigment epithelium. The outer 4 layers are supplied by short posterior ciliary artery. Short posterior ciliary artery. Short posterior ciliary artery. Okay. Short posterior ciliary artery is a branch of choriocapillaris. Choriocapillaris, matlab the capillary network of choroid. Choriocapillaris. So basically, the inner 6 layers are supplied by the retinal artery, and the outer 4 layers, because the outer 4 layers touch the choroid. The choroidal artery supply the outer 4 layers. I hope you're able to understand. The outer layer touch the choroid, that's why the choroidal artery supplies the outer 4 layers, but the inner 6 layers are supplied by central retinal artery. Inner layers retina, outer layers choroid. Inner layers retina, outer layers choroid. Okay, everybody? Done? I hope there's no confusion. Now my simple question to all of you. Both these arteries, the central retinal artery and the posterior ciliary artery, both these are branches of which artery? So they are branches of ophthalmic artery. I hope you've studied a little bit of anatomy, guys. Now ophthalmic artery is the first branch of which artery? Ophthalmic artery is the first branch of which artery? Ophthalmic artery is the first branch of which artery, guys? You want, I can't give you options for this. Ophthalmic artery is the first branch of which artery? Internal carotid artery. Internal carotid artery, guys. Okay. So branches of ophthalmic artery, and this is a branch of internal carotid artery. This is a very important fact. I will use this when I teach you. This is called CRO, central retinal artery occlusion. There will be a plaque which will travel from central carotid artery into internal carotid. From internal carotid it will travel into ophthalmic. From ophthalmic it will come into central retinal artery. So a thrombus, which will become an emboli, can travel from my heart basically, from my neck, central carotid artery to my eye. Am I clear to everybody? So it can travel from here to here only because of this pathway, and that is why it is important to remember this pathway. Okay. That's all about the blood supply of the retina. I hope you understand in terms of this. In Delhi, it is raining heavily, guys, right now. So there's a lot of disturbance outside. Okay. Just one more very little point, some specific points. Macula, an extra artery from choroid known as cilio-retinal artery. That is why in some cases of central retinal artery occlusion, in cases of CRAO, central vision is spared. I hope you understand what I'm saying. That macula sometimes receives an extra artery from the choroidal vasculature, which is called the cilio-retinal artery, from the ciliary to the retina, cilio-retinal artery. That is why whenever central retinal artery is occluded, if cilio-retinal artery is present, the macula will still be supplied. If the macula is still supplied, the macular vision will remain because it has its nutrition, and the central vision will be spared. Then very physiology point, I won't go into the details. Ganglion cells are the first site of generation of action potential. Even though ganglion cells are the third order neurons, but we say the action potential is actually generated in the ganglion cells. In photoreceptors and in bipolar cells, action potential is not generated. It is graded potential. It just accumulates and it transfers from one place to another. Okay. So if you understand physiology, you understand the difference between action potential and graded potential. So ganglion cells are the site of action potential. Photoreceptors, bipolar cells, it is graded potential. Okay, everybody. So these are just simple some points. One more question which I can tell you are what are neuroglial cells? Which cells are neuroglial in retina? Neuroglial cells in retina. So neuroglial cells in retina are obviously number one oligodendrocytes. There should be no confusion. Oligodendrocytes. Then very important cells which I mentioned a little while back, which are called as Muller's cells. And then the third cells are important cells are microglia. And then fourth, astrocytes. So these 4 cells form the neuroglial cells in retina. The rarest of these are oligodendrocytes. Rarest. Okay. So question was asked once a long time back, 10 years back, all of the following are neuroglial cells in retina except. The options were A, B, C, D. So we know Muller cells sure, we know microglia sure, we know astrocytes sure. So in that question, the answer was what, everybody? Oligodendrocytes, because oligodendrocytes are the rarest neuroglial cells in the retina. Okay, everybody. So just some extra 1 or 2 single points without explanation as far as the anatomy of the retina is concerned. I think I've taken more than enough time to teach you the anatomy of the retina. If I take any more time, you would probably start wondering why I hope all of us are clear with the anatomy, the layers, the functions, the NSR, the RT, the blood supply, and everything, guys. Okay. If we are okay with it, if you are following me, please just give me a thumbs up again so that I know that we are communicating. Okay. So a lot of you seems have given me a thumbs up. So that means all of us are on the same page, guys. So now we start with investigations in retina. Now we start with investigations in retina. So in investigations in retina, we will discuss some 7 or 8 investigations. First of all, we will discuss the investigation of ophthalmoscopy. When I say investigations, what do I mean to say? I basically mean to say that whenever a patient comes to no problem, I see double trace, no problem. So I know all the parts prior to retina are normal. That means the pathology must lie most probably in the retina, if not in the optic. So that means now I need to be able to investigate the retinal pathology. Whenever I want to investigate, what is the first thing I like to do as an examiner? I want to see the stuff with my own eyes. Yes. If there is a wound in your hand, I will first look at the wound. I will not straight away order an X-ray. You understand? So I can look at your fundus. Can I not? Yes, I can look at your retinal fundus. By which investigation? Ophthalmoscopy. So that is the first thing I will like to do. So the first simplest question I would like to ask you is, what is the use of ophthalmoscopy? So the answer should be ophthalmoscopy is used for fundus examination. As I explained to you in the beginning, there is nothing called retinal examination per se. It is fundus examination. So please never say ophthalmoscopy is used for retinal examination. Some of the students I've seen answering that fundus is examined by fundoscopy. I don't know how this word is coming to existence. There is nothing called fundoscopy, guys. There is no standard textbook which writes something called fundoscopy. Fundoscopy is an invalid word. It is only ophthalmoscopy. Okay. Now, ophthalmoscopy is of 2 types. The 2 types of ophthalmoscopy are direct ophthalmoscopy and indirect ophthalmoscopy. It's a very commonly asked question, because if as an examiner I am trying to ask you a question on investigations of retina, if I want to ask you the easiest question, obviously I will want to ask you a question from ophthalmoscopy, because as an intern you are expected, again I know we don't do any of this, but as an intern you are expected to have seen and used these instruments. Okay, so first of all I will ask you everybody, which ophthalmoscope is this, direct or indirect? Option A, option B. Everybody, poll starting, direct or indirect? The instrument you see in my hands, everybody. The instrument you see in my hands, direct or indirect? Mayank, Mitul, Shubhajit, Saurabh, Jinal, Sarat, Argaha, Ajay Kumar, you are answering it correctly. Somebody has answered it wrongly. So there is somebody who does not know this answer. Again, I'm surprised, guys. Even if you're a third year student, I would be surprised, guys. So this is which instrument? This is which instrument? Okay, 91% of you have answered it correctly. So assuming 10%, 1 or 2% people have answered it wrongly, that's what I can say. Okay, very good, guys. So this is a direct ophthalmoscope. This is a direct ophthalmoscope. Please remember, this is a direct ophthalmoscope. I hope all of you can see this. If you can't see this properly, then I'll also bring up an image for you so that you don't tell me after a while, sir, we could not see. So please see, this is a direct ophthalmoscope. So same thing that you can see in my hand, the same thing is this direct ophthalmoscope. You hold it in your hand. Okay, everybody. Now I'll show you another instrument, and that instrument will obviously become the indirect ophthalmoscope. So everybody, this, we wear it like this. Okay, everybody, this is which ophthalmoscope, guys? You can see at my head. This is your indirect ophthalmoscope. If I start a light, this will appear like this. Okay, the light will go out from my instrument like this. Okay, so this is called an indirect ophthalmoscope. I hope we are clear about this. There's no confusion. So this is an indirect ophthalmoscope. Okay, guys. So again, I'll just bring up a photograph of the indirect ophthalmoscope also on screen for you. So everybody, you can see this is an indirect ophthalmoscope, the same thing that I just worn over my head, but you can still see hanging at the back of the screen if you can see the screen, guys. Okay. So first of all, the basic thing is you should be able to identify both the ophthalmoscope, direct ophthalmoscope and indirect ophthalmoscope. If you want to find it, remember this. If you can't remember it like this, I'll make you remember like this. There are 2 ways of earning money. One is direct, one is indirect. Direct means by doing hard work. Hard work is done by hands. You understand? When you're doing some hard work, you're doing work by hands. So the instrument which you hold in your hand is direct. Indirect in Hindi, if I say dacoity, चोरी करना, किसी के सर पे टोपी पहनाना, ऐसे कहते हैं ना, सर पे टोपी पहना के पैसा कमाया, right? That's an indirect way of earning money. So when you wear something over your head, that's an indirect way of earning money, or indirect ophthalmoscopy. If you can remember it just like this, I'm very happy. If you need a trick to remember, this is the basic trick. Now, what are the differences between direct ophthalmoscopy and indirect ophthalmoscopy? That's the basic question that we want to answer here. What are the differences between direct and indirect ophthalmoscopy? So the first question I ask is, through both direct and indirect ophthalmoscopy, we are looking at the fundus and we are trying to look at the retina. In retina, we are, let's say, trying to look at the optic disc. What was the diameter of optic disc, guys? 1.5 mm. That means the optic disc is very small. So the first thing, as soon as I'm using an instrument, I know there is a lens in this instrument, I will like to magnify the image. When I magnify the image, I will be able to see it more clearly. I will be able to see the details more clearly. So that is the first point of difference. What is the amount of magnification present in both the types of ophthalmoscopy? So for direct ophthalmoscopy, the magnification is 15 times. Whereas for indirect ophthalmoscopy, it can vary from 3 times to 5 times. Indirect ophthalmoscopy, 3 to 5 times. Now, if there is some magnification happening in both the ophthalmoscopies, that means I must be using some kind of a lens. Now, this is very basic, very common, guys. Which type of lens is magnifying lens? We have all used a magnifying lens in our childhoods. Convex lens or concave lens? Anybody? Which type of lens is magnifying? Convex or concave? Option A, convex. Option B, concave. Convex or concave? Quickly, guys. Which type of lens is magnifying? Convex or concave? Convex or concave? Again, there is somebody who's wrong. There is somebody who's wrong. We can't be wrong in this basic stuff, guys. Whosoever is wrong will get to know it himself or herself, guys. We can't be wrong. Almost everybody is right. So the answer is convex. Convex lenses are magnifying lenses. Concave lenses are minimifying lenses. Okay. So almost everybody is correct. Only I think one person is wrong again. So the lens which we use is convex in both the cases, direct as well as indirect. In both the cases, we are magnifying. Now, if you've seen the instrument, everybody, again, see this instrument carefully. In my this direct ophthalmoscope has a lens fitted here. The power of the lens, I'll just try to bring it. The power of the lens can be rotated from this lever. I can change the power of the lens. Okay, everybody. So the power of the lens can be rotated from here. Okay. So there is a lens already fitted in this. The power of the lens can change from plus to minus to whatever. But in an indirect ophthalmoscope, there is no lens. We need to use an external lens. So what is the most common power of lens used along with indirect ophthalmoscopy? This is the question which is asked, and the answer is plus 20 diopter. Please remember this. Plus 20 diopter. So this is a 20 diopter lens, guys. If you've never seen it, you can see on the box it is written 20D. You can see on the box it is written 20D. Okay, so this is what a 20 diopter lens looks like. You can see here. I don't know if you can. Can you see, guys? You can see also one more thing. As soon as you're looking through this lens, my image looks what, everybody? That's my next question. My image looks inverted or erect? Everybody, can you see? My image looks inverted or erect? See, everybody. See, everybody. My image looks inverted or erect? Inverted. That will be my next question to all of you. What is the image fault? So if we've been able to see it, we know that in indirect the image is inverted, and inverted images are real and inverted. So if the image formed in indirect is real and inverted, the image formed in direct. Everybody, can you see? My image looks inverted or erect? See everybody. See everybody. My image looks inverted or erect? Inverted. That will be my next question to all of you. What is the image fault? So if we've been able to see it, we know that in indirect the image is inverted, and inverted images are real and inverted. So if the image formed in indirect is real and inverted, the image formed in direct will be virtual and erect. Virtual and erect. Okay, everybody. If you can remember by my video that I've just shown, it's okay. Otherwise, if you want to just remember theoretically, I for indirect, I for inverted. I for indirect, I for inverted. And if indirect is inverted, obviously inverted is real. I hope that you do know this much, or do you do remember this much by yourself, guys? Okay, everybody. So these are the first three differences. Now, if I move on, the next important point that I want to differentiate is what is the area visualized. Now, this is something that we want to understand. If we understand this, this becomes easier to answer. Again, this is direct, this is indirect ophthalmoscopy. So what is the area visualized? Now, what do I mean by area visualized? See, I said in ophthalmoscopy, it is a view of the fundus. Ophthalmoscopy is a view of the fundus. If it is a view of the fundus, a view has an area. Meaning what, guys? Let's say I take my phone out. Okay. Let's say I want to click the photograph of the whole room I can see. That means the area of view has to be larger. If I want to click a few photograph of the whole room, then the area visualized has to be larger.